Hello friends, I am NK Jain from Skill on Tech. In the series of pump interview questions, I am presenting part 3 of 200 interview questions, question 21 to 30. The topic is unbalance in rotating bodies. What is unbalanced force in rotating bodies? Rotating unbalance is the uneven distribution of mass around an axis of rotation. You can see a picture where axis of rotation and center of gravity means inertia axes are different. A rotating mass or rotor is said to be out of balance when its center of mass inertia axis is out of alignment with the center of rotation geometric axis as shown in the sketch. Unbalance causes a moment which gives the rotor a wobbling movement, characteristics of vibration of rotating structures. This eccentricity, perpendicular distance between axis of rotation and center of gravity, is generally expressed in units mm. How to calculate unbalanced force in rotating bodies? You can see a picture where a center of rotation is shown and a center of gravity, center of mass is shown differently. You can see a F unbalanced force and a perpendicular distance E between center of rotation and center of mass, that is called eccentricity. Unbalanced force is produced in a rotor or a component mounted on a rotor that has center of gravity inertia axis not coincide with the axis of rotation, as shown in the picture that center of gravity and center of rotation are not coincide and they are different. When this occurs, a inertia force is generated due to rotation of the shaft that is defined by F equal to m into E into omega square. Unbalanced force F equal to force caused by the imbalance. M is the mass of eccentric part or rotor. E is the eccentricity of the part or rotor. Distance from the center of mass to the axis of rotation. Omega equal to shaft speed in radian per second equal to 2 pi n upon 60, that is linear speed. N equal to shaft speed in rpm. Sketch type of pump impeller unbalance. You can see sketch 1 where a static unbalance is shown. So when static unbalance will occur? When axis of rotation and principal inertia axis both are different and an unbalanced mass is on the rotor. Center of mass means inertia axis is different and there is an uneven distribution of mass. One single mass is shown as an unbalance. So in these kind of condition, a static unbalance will be adjusted in the rotor. You can see sketch 2 where a couple unbalance is shown. In couple unbalance result when a rotating shaft has two equal unbalanced masses in two different planes that are 180 degree apart from one another. So you can see there are two different planes are shown. Unbalanced mass in P1 plane, unbalanced mass in P2 plane, and center of mass and geometric axis both are intersecting. So this is the condition of couple unbalance. This result in the axis of rotation passing through the principal mass axis, but it is not parallel to it. So this kind of unbalance is called couple unbalance. Now you can see sketch 3, a dynamic unbalance is shown. You can see in a dynamic unbalance, it is a common type of unbalance. It is a combination of static and coupled unbalance. So here you can see in the sketch, the principal inertia axis and axis of rotation are not intersecting, neither parallel. So dynamic unbalance causes the system to tilt or wobble. To compensate this, weight must be added in two different planes. What is static unbalance? A static unbalance, sometimes called a force unbalance, occurs when the inertial axis of rotating mass is displaced from the axis of rotation and is parallel to it. You can see in this picture, this is a shaft axis, axis of rotation, and this is a mass axis. So both are parallel, and this is a unbalanced mass which is shown here. Static unbalance can occur more frequently in disc-shaped rotors because the thin geometric profile of the disc allows for an uneven distribution of mass with an inertial axis that is nearly parallel to the axis of rotation. Only one plane receives balance correction. So in the static unbalance, only single plane balance correction is required. U equal to m into r, where U equal to unbalance, m equal to mass, r equal to distance between unbalance and center of the object. What is couple unbalance? A picture of couple unbalance is shown. Geometric axis, this one, and this is a mass axis. Both are intersecting. A couple unbalance occurs when a rotating mass has two equal unbalanced forces that are situated 180-degree opposite each other. So here you can see this is a one unbalanced mass and this is a another unbalanced mass, and both are in different planes. This is plane P1 and this is plane P2. A system that is statically balanced, center of mass on rotation axis, may still have a couple unbalance. Couple unbalance occurs frequently in elongated cylindrical rotors. U equal to m into r into d, where U equal to unbalance, m equal to mass, d equal to distance between the two unbalanced forces along the rotation axis. So here you can see this is the distance d. What is dynamic unbalance? In rotation, when the mass, inertia axis and shaft axis are not parallel and do not coincide, as we discussed earlier, then it is called dynamic unbalance. Dynamic unbalance is a combination of static and couple unbalance. The sketch of this dynamic unbalance is shown in the next slide. That will clear your understanding. It occurs in virtually all rotors and is the most common kind of unbalance which occurs in the pump impellers and rotors. It can be fixed by correcting the weight on at least two planes. Rotors of the same type having permissible residual specific unbalance value EPR varies inversely with the speed of the rotor. EPR into omega equal to constant, where omega equal to angular velocity radian per second, EPR equal to permissible residual specific unbalance gram mm per kg. Here you can see a dynamic unbalance condition where you can see the center of gravity and axis of rotation are neither intersecting nor parallel. So there are two different unbalanced masses in two different planes. So this is a condition of dynamic unbalance where a static unbalance as well as couple unbalance exist. What are the causes of mechanical unbalance in pump impellers? You can see a picture of a impeller where blades are damaged and a heavy erosion and corrosion has occurred in the impeller. Rubbing contact and mechanical removal of material. So there may be a rubbing of between rotating components and stationary components of the pump casing, and that may cause a removal of material from impeller or casing. So it will increase clearance gap. Clearance gap represents the clearance between vane tip and casing wall and has a considerable influence on the pump performance. If a impeller wearing ring clearances will increase, there will be a loss of fluid because fluid will goes back to the suction and it will reduce the performance of the pump. Asymmetrical erosion as a result of abrasive fluid handled. Asymmetrical corrosion as a result of aggressive fluid handled. Asymmetrical deposition of crystallized fluids or fluids prone to sedimentation. If fluids are prone to sedimentation, then they will deposit on the impellers or rotating components and will create an unbalance that may cause to heavy vibrations in the pump. What are the causes of hydraulic unbalance during operation of pump? Uneven action of vane or channel caused by geometrical unevenness, shape or roughness. Uneven energy transmission caused by vanes with differing cavitation behavior. Suppose your pump is under cavitation condition, then there may be uneven energy transmission and that may be a cause of unbalance. Hydraulic unbalance occurring with a single vane impeller due to their design principle. What are the effects of pump impeller unbalance? Vibration, noise, decreased life of bearings, unsafe work conditions, reduced machine life, increased maintenance. So let us understand why impeller balancing required. Balancing can prevent the vibration while increasing efficiency. So impeller balancing will reduce your vibrations and it will increase the pump efficiency. Without providing balance to pumps, noise cannot be reduced. Higher operating speed cannot be achieved and bearing life of pump shortens. By being slightly off, the level of efficiency reduces the pump input power, putting an end to energy wastage. So your unbalanced impellers will also reduce your pump efficiency level and your pump input power will be increased. So there will be a wastage of energy. This can also lead to accident to servicemen and employees. Unbalanced impeller can cause to damages to the pump and components may damage to working technicians or employees. Thus, impeller balancing ensures that the speed and efficiency of equipment meets standard while protecting against cavitation. Balancing is always one of the most cost-effective ways of ensuring quality of equipment. So therefore, impeller balancing is must for all the pumps. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.